Okay, so we are now getting into the part of geometry that's going to be a little bit more tricky than not. We are starting proofs tomorrow. Today is going to be how we get set up with proofs. But you need to know how to solve equations. Today we are doing algebra reasoning. So we're going to talk a lot about the real number system. We're going to talk about properties. We're going to talk about all that. So when we have our equation, we find our balance point. Balance point's the equation. We have a left side, right side. Okay? First step always, distribute if needed. You guys have that paper that said all the rules. Distribute means I'm multiplying. We're taking whatever smack dab in front of the parentheses and distributing it to everything else. The 5 wasn't touched, it comes down. Negative 3 times 2x is negative 6x. Negative 3 times 4 is negative 12. Equals 3x minus 9. Well, I'm not done with this side. Combine like terms. 5 minus 12. 5 minus 12 is negative 7 minus 6x equals 3x minus 9. Okay. From here, I like to move my smaller variable. So that's negative 6x. I use inverse operations. Negative 6 plus 6, that's the additive inverse. That's 0. Negative 7 drops down equals 3x plus 6x is 9x's. Minus 9 comes down. Add 9 to both sides. That gives me 9x equals positive 2. Divide by 9, x equals 2/9. What questions do we have? Anybody's? Who got it right? Oh. So then I should be seeing you copying down the correct thing. If you missed it, you should have it correct because you need to know how to solve equations.
The only thing I didn't do, I didn't distribute the negative 3, I just did positive 3.
Gotcha.
Yeah.
Nice. That was nice.
That's one. Wait, is it hot outside?
Like 75.
Oh my gosh. It's early in the morning and it's
Lucy,
cold.
what does that mean exactly? Like, I don't know if you're excited or upset that it's nice outside.
Upset.
I hate, like, I needed to cool down. I'm sick of the hot weather. And I
Agreed.
work today, and we literally are just outside the whole day.
It's not hot.
Where do you work, Lucy?
Gap. And then elementary. And we just sit outside.
Okay.
I like 50 degrees.
So I like it when it's cooler.
Okay. Sorry.
Well, it's not hot.
Okay, here we go. Everybody good?
I like 50 degrees as well.
No?
50
Come on, let's go.
Perfect.
We are going to be taking new notes. So once you're done with the warm-up, 9, 25, 24, 1.5, algebraic reasoning, that's what we're starting with. Bless you.
Thank you.
You're welcome. Sorry. You're fine. Daniel, I'm giving you like 30 more seconds, man. Is this in the way for you, or are you going to sleep? If you need to, you can always just move. Ten, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Okay, so today what we're starting with is the real number system. Okay, so I'm going to take up a good bit of the board. You're probably going to want like half of a page to have this. So I'm going to start with the big box. This is the whole box is the real number system. The whole thing is the real number system. Because right now, you don't know what imaginary numbers are. It's I. It's the square root of -1. You don't need to know that. You'll learn that in Algebra 2 if you have me next year. But, real number system. Any number that you can think of is part of the real number system right now. When I teach my kiddos, who are 6 and 4, almost 7 and 5, But when I was teaching Cole, my son, how to do math, I asked him to learn to count. Okay, Cole, we're going to start counting. You ready, buddy? 1, 2, 3, 4, 5. Those are the counting numbers. Is anybody in here go, oh, I'm going to count? -4, -3, is that where you start counting from? If I asked you to count, Julian, start counting.
1.
Yeah, you start at 1, right? Like you're not going to look at me and be like, you jerk. 27, 28. No, we start at 1. Those are our counting numbers. Our counting numbers have a name. And they are called natural. Our natural numbers are the counting numbers. Everything begins with those natural numbers. And I can tell that some of y'all have never done hard work. Some of y'all are soft. I can tell. But every book.
Who?
Lucy.
Me right here.
Lucy's like, I can't sit outside. It's 74 degrees. Oh my gosh. I'm not saying you're soft at all.
Okay.
I'm not saying you're
How
soft
dare
at
you
all.
mock her? How
You're
dare
gonna
you?
fight because you don't understand.
Okay, help me. Go ahead. What don't I don't understand a lot of things, but go ahead.
Are you saying I don't do hard work?
I've never once said that. You said that actually.
You just said
that.
there's some of you that are soft
And you
then
said who?
Yeah, I asked and then you said me. So
I didn't say you.
myself. Yes, you did.
No, I
You
did.
literally said, Lucy can't even stay outside to tell me.
I did say that. I never said you're soft.
Yeah, so it's obviously.
You are mocking her.
So who?
You can think whoever you'd like. But
Whatever.
I have dug many a hole in my day. I'm also much older than you. But I've had to plant things, and I've dug a hole. What number does a hole look like? A 0. The next set of numbers from natural are called whole numbers. And whole numbers aren't spelled H-O-L-E, but W-H-O-L-E. The only difference between natural and whole is the number that looks like a hole. 0. So whole numbers start at 0, go 1, 2, 3, 4, and so on and so forth. Lucy, I'm sorry that you thought that I was talking. Why would you think that I would think you were soft?
Do you think I'm upset or something?
No, you sound like you're upset. I mean, come on.
Wow.
You don't understand.
I don't understand a lot.
I have a blue collar dad.
Okay.
You don't understand what we have to do.
What do you have to tell me? I want to understand.
My dad.
Hold on.
Okay. Oh, if you have a blue collar dad,
Wait.
you understand.
Go ahead. I do have a blue collar dad. Go ahead.
He makes us work every Saturday when
Okay.
we work outside.
Yeah.
We have a farm.
Oh,
We work on
yeah.
the farm every Saturday.
Uh-huh.
When it's winter time,
Yeah.
we have to go and split wood.
Okay.
Even the
And, oh my
trees.
gosh. And then what?
I'm just saying, you
Oh.
don't know.
I don't. Anything else? Okay. I wanted you to know that you had my full attention.
Oh yeah, I can tell.
I love you too, Lucy. I do have a blue
I
collar
love
dad.
the sarcasm here.
Okay. There was no sarcasm.
There was a lot of sarcasm. You didn't hear it?
No, I heard nothing but Lucy and I having a conversation.
If you didn't hear it,
Okay, so next are whole numbers, but now we need their opposites. The opposite of the whole numbers is integers. So what this means is we're going to have them going forever and ever and ever this way, but something like -4, -3, -2, -1, 0, 1, 2, 3, 4, and so on. It's just the whole numbers and their opposites. Notice what we don't have so far. We don't have decimals, and we don't have what else? Fractions. Neither of those are part of it. Then in the rest of this box are what are called rational numbers. Rational numbers are any number that you can write as a fraction. 1/2. 22/7. What else? Decimals that end. 1 2/10. Decimals that repeat. 1.3 with the bar over it. Okay? Anything that can be written as a fraction or a decimal that ends or repeats, a terminating decimal or a repeating decimal. Those are rational numbers. There is a very big idea with this. And it is the arrow that goes out. Notice where that arrow starts. It starts in a natural number. If I say, give me the sets that the number 2 is in. 2 is a natural. It's also whole, it's also an integer, it's also a rational, and it's also real. It goes out, but it doesn't go back in. So an integer, -4. -4 doesn't go this way. It goes this way. -4 is an integer, right here. It's also rational, it's also real. Okay? But what's this side? Well, this side is called irrational. Irrational numbers are numbers like pi. Why? Because pi is a decimal that never ends and does not repeat. So it would look something like this: 3.14256711139 ... and it goes on forever, not repeating. Okay, that's not really pi, that's just a decimal that I made up. Okay? Another type of irrational number. We have perfect squares. The square root of 4 is 2. The square root of 9 is 3. The square root of 144 is 12. But if you put into your calculator the square root of 31, it would give you a decimal that would go on forever and ever. Now, would you see that in the calculator? No, because the calculator can't go forever. But any non-perfect square is irrational. What types of questions could you see? Well, name all subsets. And I might give you the number 25/5. And you're going to tell me which number, what name is 25/5. Now, before you go, oh, it's a fraction, so it's rational. Yes, you're correct. But can we simplify it? What is 25/5?
5/5. Or no.
5/1.
5/1, which is just 5. So really, this is 5, which makes it a natural. What else? Whole.
It's an integer.
An integer.
It's rational.
It's rational.
And it's round.
And it's real. So notice how that arrow goes out. Questions there. Make sure you have this copied down because I'm going to erase it in a second. And if you have your books, it's going to help you to open to page 78. Give me 2 minutes, I will be right back. Go to page 78, please.
You guys have gum?
I have some.
Can I have a piece?
Yeah. I don't like the mint taste, but I get over it eventually.
Do you like the green one? I have another pack of green.
I more so like watermelon flavored.
I like mint. Sorry about that.
That's fine. I'll have to bring my own one eventually. But I'm chill with whatever, really. I feel like Mr. would come closest listening, and I swear he is always like to leave.
I saw your mom at Quaker this morning.
Oh, what?
I saw your mom at Quaker this morning.
Ah, yeah.
Did she tell you?
No.
Oh.
I don't think she saw you.
She said hi to me.
Oh, never mind. But no, she didn't. Well, she did pull up that she asked me if you and Bo were siblings.
Yeah,
And I said, yeah, they're twins.
What'd she say?
And she's like, that makes sense, much more simpler.
Yeah. No one knows. Really.
Oh, no, your friends, you look so much alike.
Actually?
No.
Well, you don't act alike, but you look a lot alike.
You do not look or act like.
They do too, if you look closely.
I mean, their hair looks the same.
It's just, you can tell like me and my siblings are like, because our hair like all the same.
You both look like your parents, though. It's weird.
Really? Like, I look like my mom, that looks like my dad.
You
Sorry.
both look like both.
Okay, here we go.
You don't look alike.
So we have this all copied down, yes? So now we're going to start talking about the real number properties. And I apologize for that delay. You're good, you can finish your conversation as long as it's appropriate.
Because you look more like your mom than your dad.
Yeah. I get that a lot.
I never met your mom or your dad, so I wouldn't know.
Yeah.
Okay, here we go. So, first property we're going to talk about is the identity.
Oh, hey, I knew
And there are two different types of identity. There's the additive, and there's the multiplicative. And you have heard me talk about this identity as we've done equations. The additive identity says anything plus 0 equals the anything. Anything plus 0 equals the anything. Anything plus 0 equals the anything. Because you've heard me say x plus 0 equals x. Well, what about the multiplicative? Well, same idea, but if I have 5 times something equals 5, what do I have to multiply by to get the same thing?
Just saying number.
No,
1.
by 1. 5 multiplied by 1 is 5. Negative 3 multiplied by 1 is negative 3. 1/4 multiplied by 1 is 1/4. Same thing with inverse. And again, these are things that you've seen. We have the additive inverse. We have the multiplicative inverse. We've done these. How do I know? Because we just had an equation where we've done both of these. So the additive inverse, you have negative 3 plus 3 equals 0. 5 plus a negative 5 equals 0. And I'm going to put 5 minus 5 equals 0. Why? Because those are the same. Even though they look different, they're equivalent. 1/4 minus plus a negative 1/4 is 0. The multiplicative inverse talks about the reciprocal. So negative 3 multiplied by negative 1/3. Oh, hold on. Yeah, that's fine. Equals 1. 5 multiplied by 1/5 equals 1. 1/4 multiplied by its reciprocal, which is 4/1, equals 1. Those are the inverse properties. The commutative, not commutative, commutative, says it doesn't matter the order in which I add things. 3 plus 4 equals the same as 4 plus 3. Same idea with multiplication. It says it doesn't matter if I do 3 times 4 or 4 times 3. And again, these are things that you've seen already. The associative, and then we only have, let me try this again. We only have addition and multiplication, right? Okay. The associative, which I do not want you abbreviating for reasons. The associative is positive or multiplication, and this talks about parentheses. This says if I group, bless you, 3 plus 4 plus 5, that's the same as saying 3 plus the grouping of 4 plus 5. Those are the same. Or I can multiply 3 times 4 times 5 is the same as saying 3 times 4 times 5. Wow, Mr. H, that is stupid. There we go. And then the distributive property is simply taking what's in front of the parenthesis and multiplying. We've already done that. I'm not going to write that down.
You annoy a lot of people in high school, don't
Yeah, I still am. I'll give you one more minute. I'm sorry, Esther, what?
So I can't concentrate on two different things at once.
I'm sorry for that. Focus on one thing. That's the point.
I know it's everything. It's the ADHD issues.
So what are you afraid of, like,
Ooh, snakes.
us? Oh, I'm afraid of snakes too.
Oh,
I got
terrifying.
bit by a snake.
It's terrifying.
Cobras?
Was that, no, just snakes. Was that your question? What am I afraid of? Snakes.
No, what are you afraid of, like, us abbreviating associative? Like,
Really?
yeah.
Shut up, Daniel.
I'm more afraid of spiders and snakes.
I'm sorry that you're a wuss.
But I'm not afraid of snakes.
Well, snakes are...
You'd think that.
Here we are. Are we good?
Yeah.
Daniel?
I'm writing down associative.
You'd think that you could kind of crush a snake's skull, is what I would do.
I mean, I don't like snakes by any means, but I just don't mind them.
Listen. Somebody comes in here looking to hurt y'all, I'll fight them tooth and nail. A snake comes in here, I'm pushing you all over and running as fast as I can.
That's
You guys
ridiculous.
My
can
mom would do the exact same
You
thing.
could throw a book at a snake.
Well,
My neighbor
okay,
got
okay,
bit by
my
a
mom
tiger.
wouldn't run.
That's what I got bit by.
Okay, my mom would run, but she would also
Wait, by
set
what?
school on fire if that happened.
A weekend.
Yes.
in the hospital. It's pretty good.
Okay, here we go. So, you scared of
Dang,
snakes?
wasn't it at like your mailbox
You
or
scared of
something?
snakes?
You told the story about you getting bit.
Okay, here we go. So, these were real number properties. Now we're talking about something that you probably haven't done. The properties of equality. And listen, you're going to need to know these. So make sure that you have these written really well. The reflexive property. And I'm going to abbreviate property as prop. A equaling A. Or 7 equals 7. Or the measure of angle ABC equals the measure of angle ABC. It has to be the same on both sides. Reflexive, reflection. Think about looking in the mirror. Okay? You're getting the same exact thing. That is the reflexive property. The symmetric is if A equals B, then B also equals A.
Isn't that integrity?
Is that A equals that? Under-
A equals B, then B equals A. What, Esther?
Isn't that, somewhere in mind, I was gonna say deductive, but what was the other one? What's the?
Inductive?
Yes.
No.
Like, what is the word? It's like
Syllogism?
syllogism.
Kind of, but not there. Okay? Transitive is more like our law of syllogism. That transitivity. So the transitive property is very similar to the law of syllogism because transitive says if A equals B and B equals C, then
A equals.
A equals C. And I promise in geometry, this one is going to be very, 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 very important. Because I'm going to be able to say, well, this angle is congruent to this angle. If this angle is congruent to this angle, then this angle is also congruent to this one, which means these two are congruent. This is how we're going to start proving things. Okay? Then we have the addition problem. Wow, not problem. Addition property. And this says something like this. A plus C equals B plus C. So what that means is if I have x plus 7 equals 14, let me make this a minus 7, I can add 7 to both sides. That's the addition property, okay, which you have seen. The multiplication property, last one, as my behind's just sticking out there, sorry, says A times C equals B times C. So if I have 1/4 x equals 4, if I multiply this side by 4, I can multiply that side by 4. And that stays the same. As long as we're multiplying both sides by the same thing. A lot of properties, a lot of properties, a lot of just definitions. Okay, so here's what we're doing. Page 80 and 81. You're doing 1 through 19. Page 80 and 81, 1 through 19. I'll help you. You can ask questions. Okay, I know it was a lot, but it's all on the real number system and these properties.
What numbers did you say?
80 and 81. Let me write it on the board. I've been yelled at before. But you know what I do? Is I do try to learn. Homework is on page 80 and 81. You are doing numbers 1 through 19. If you do it well, you should finish before this class is over. You have just under 20 minutes.
Mr.
Okay? Yes,
Do you want to see the homework?
I do.